Somewhere in the distant universe, astronomers found an object unlike anything they had ever seen before. It was so unbelievably powerful that it outshined an entire galaxy, shining across billions of light-years of empty space. But when scientists finally calculated what could possibly be producing that incredible amount of energy, the answer didn't make sense. According to everything we understand about the universe, an object this massive shouldn't even exist. So, what exactly did astronomers discover? And did the universe somehow break its own rules? In this video, we'll uncover the incredible story behind one of the most extreme objects ever found, why scientists still struggle to explain it, and what it may reveal about the hidden limits of our universe. Let's get started. It all started with what looked like an ordinary blue dot. Back in 1957, astronomers at the Tan Cinta Observatory in Mexico were photographing thousands of faint blue objects across the night sky. Most of them turned out to be exactly what scientists expected: distant stars and galaxies. One object, however, received the simple catalogue name to N618. For years, nobody paid much attention to it. Then, astronomy changed forever. During the 1960s, scientists began discovering a completely new class of mysterious cosmic objects known as quasars. These weren't stars at all. They were some of the brightest objects in the universe, releasing more energy than entire galaxies. When researchers looked back at 618, they realized it belonged to this extraordinary new class. Unlike what many people imagine, astronomers weren't looking at the object itself. They were looking at an astonishing amount of energy coming from something hidden deep inside it. The obvious question became, what could possibly generate that much power? As telescopes became more powerful and measurements more precise, the answer slowly began to emerge. It wasn't a giant star. It wasn't an entire galaxy. It wasn't even a cluster of galaxies. It was a single giant black hole, one containing roughly 66 billion times the mass of our Sun, making it one of the most massive black holes ever identified. For a moment, astronomers could hardly believe the calculations. How could one object become so unbelievably enormous? Finding the biggest known black hole would have been remarkable on its own. But the real shock wasn't its size. It was what that size implied. Because according to our best understanding of how black holes grow, Ton 618 should never have been able to become this massive in the first place. Imagine trying to fill a glass that's already full. No matter how much more water you pour in, it simply spills over. Surprisingly, astronomers believe black holes face a similar problem. Most people imagine that a black hole can keep growing forever simply by swallowing more and more matter. In reality, the universe seems to place a limit on how quickly a black hole can grow. As enormous amounts of gas spiral toward a black hole, they don't fall in quietly. Before crossing the event horizon, the gas becomes unimaginably hot, releasing tremendous amounts of energy. That energy pushes outward, making it increasingly difficult for fresh material to continue falling inward. In other words, the faster a black hole feeds, the more it begins to slow its own growth. For decades, this idea has helped astronomers explain why black holes grow the way they do. Then, Ton 618 came along. Its estimated mass doesn't just stretch those limits, it pushes them to the edge of what current theories can comfortably explain. So, how did it happen? Did Ton 618 spend billions of years feeding almost continuously? Did it grow through countless mergers with other black holes? Or did it begin life under conditions that no longer exist in today's universe? The truth is that astronomers still don't have a single answer. Every explanation solves part of the puzzle, but none explains the whole picture. And that's what makes Ton 618 so fascinating. It isn't just one of the biggest black holes we've ever found. It's one of the biggest unanswered questions in modern astronomy. For years, astronomers treated Ton 618 as something extraordinary, an almost impossible object that somehow managed to push the limits of everything we thought a black hole could become. Then the universe delivered another surprise. As the James Webb Space Telescope began looking deeper into space than ever before, it was also looking further back in time. What scientists expected to find were young galaxies, young stars, and black holes that were only beginning to grow. That's not what Webb found. Instead, astronomers started discovering enormous black holes already sitting at the centers of some of the earliest known galaxies. Many of them appeared far too massive to have formed in such a short period of cosmic history. It was as if the universe had somehow skipped millions or even billions of years of expected growth. Suddenly 2N618 didn't look like an isolated mystery anymore. It looked like part of a much larger pattern. Most people think 2618 is remarkable simply because it's enormous. In reality, what makes it truly fascinating is that discoveries like it are forcing astronomers to question whether our current picture of black hole evolution is complete. That doesn't mean our existing theories are wrong. Far from it. They successfully explain many of the black holes we've observed across the universe. But every time astronomers discover another cosmic giant that appears earlier, grows faster, or reaches a size that seems unexpectedly large, those theories are pushed a little further. Science advances exactly this way. Not by finding objects that fit perfectly into existing ideas, but by discovering the rare exceptions that force us to ask better questions. T618 is one of those exceptions. It reminds us that the universe isn't obligated to follow the expectations we've built from the observations we have today. Instead, it constantly challenges us to improve those ideas as new evidence arrives. And perhaps the most exciting part is that we're only entering a new era of discovery. Over the next decade, powerful observatories like the Vera C. Rubin Observatory, the Nancy Grace Roman Space Telescope, and future generations of radio telescopes will survey the universe with a level of detail we've never had before. Rather than studying only a handful of extraordinary objects, astronomers expect to uncover thousands of previously unknown quasars and supermassive black holes across cosmic history. Some may look very much like T618. Others could be even more surprising. Imagine discovering a black hole that formed even earlier than current models allow, or one significantly larger than anything we've measured so far. Neither possibility can be ruled out. History has taught astronomers something remarkable. Nearly every time humanity builds a more powerful telescope, the universe reveals something we never expected to find. From the discovery of quasars to the first image of a black hole to Webb's observations of the early universe, each generation of instruments has expanded the boundaries of what we believed was possible. There's no reason to think that pattern will suddenly stop. So perhaps the biggest mystery surrounding T618 isn't whether it's the largest black hole we've discovered. Records are made to be broken. The real mystery is whether T618 represents the upper limit of what nature can create, or whether it's simply the first glimpse of an even more extraordinary population of cosmic giants still hidden in the depths of the universe. And if the history of astronomy has taught us anything, it's that the universe almost always turns out to be stranger than we imagined. T618 may be one of the largest black holes we've ever discovered, but its greatest mystery isn't its size. It's what it reveals about the universe. And if history has taught us anything, it's that the next discovery may be even more impossible than the last.